In today's lesson, I'm going to do a few problems of how to solve absolute value inequalities, and I will be solving them algebraically and then we'll check it graphically. So let's get started. The first inequality is absolute value of 2x minus 4 less than 4. So to solve the inequalities, you need to know a certain properties here, and these are the properties which is for equal to, which we use for solving absolute value equations, and these are the properties which is useful for inequalities. So make sure that you know these properties, and the most important property which we are going to use is number 8, and here for the last property, number 8 property is the most useful property here. So according to this property, if absolute value of A is less than equal to B, then A is between negative B and B, and negative B and B is included. So this is if it's with included, this inequality is with included. If this is strictly less than B, then here also you will have strictly less than B. The another one is this one. This actually consists of two parts here. So this one is if absolute value of A is greater than equal to B, then A is less than equal to negative B, or A is greater than equal to B. So these two properties are the most useful properties which we are going to use to solve absolute values inequalities algebraically. So the first one we have to show is 2x minus 4 is less than 4. Now we know that if absolute value of A is less than B, then A has to be between B and negative B. As I already mentioned, this can be with equal to sign and without equal to sign. So here, which means this 2x minus 4 is between 4 and negative 4. And now if I add 4, so when we are solving this inequalities, we are doing exactly in the same way as we solve the equations. So the first step you will do is you add 4 so that you can get rid of this negative 4. So when I add 4 here, so if I add 4 here, so 4 here, 4 here, then I get this is 0 and this becomes 8. And then x is 4 and 0, divide by 2. So exactly the same way. So the solution for this inequality is x lies between 0 to 4. So this is the answer. So for the difference between absolute value inequality and equation is that you get numerical answer which is equal to, whereas in inequality you will get an inequality as an answer, not equal to it. So not a specific values, but you will get a inequality in this. So we got 0 less than x less than 4. So I'm going to now check it using the calculator here. So we have to do absolute value of 2x minus 4 less than 4. So there are multiple ways to enter absolute value. I prefer to use second 0, which is catalog, and then press on absolute value, and then this is 2x minus 4. And then you have here less than 4. So y2 is less than 4. Graph it. And from graph, you can identify what will be the solution for this one. So we need the absolute value to be below, less than 4. So 4 is this. So less than 4 is below this line. Below this line. And for this one, you can see it is from 0 to 4. So you can see from here, then x must be between 0 to 4 in this case. If we want the absolute value to be below x is equal to, y is equal to 4, sorry. Okay, so this is how you can check graphically. So if we can sketch it, so the sketch looks like, I'm just sketching here like this and then this. So this is the graph of 2x minus 4, and this is y is equal to 4. So this is the area we are talking about. This is 0 and this is 4. So the solution is between 0 to 4. Okay, 0 and 4 is not included. Now let's move to the second one. Here the second one is 3 minus 2x is greater than equal to 1. So the property which we are going to use here is this one. So if absolute value of A is greater than equal to B, or if greater than, here we have both included, so absolute value of A is greater than equal to B, then we know that A has to be less than equal to negative B, or A has to be greater than equal to B. Okay, so this property is the most important. You need to know this property. Now a is 3 minus 2x. So 3 minus 2x is less than equal to -1, or 3 minus 2x is greater than equal to 1, because a in this case is 3 minus 2x and b in this case is 1. Okay, now after that you just solve it the way you solve your equations. So minus 2x is less than equal to -1 minus 3, minus 2x is less than equal to -4, or minus 2x is greater than equal to 1 minus 3, minus 2x is greater than equal to -2. Now I have to divide by -2 in both. When you divide by a negative number, the inequality sign changes. So when you divide by a negative number or multiply by a negative number, the inequality sign changes here. So x is greater than equal to 2, or x is less than equal to 1. Now I'm going to, if I draw this, the solution looks like this. So if this is 1, this is 2. So x is less than equal to 1, it's included. So here, if I represent this on number line, and greater than equal to 2, the solution is here. Now let's confirm it using the calculator. So I'm going to clear this, y1, and so delete, and y2, delete 2. Okay, so now we need to enter here absolute value. So again, second 0, 3 minus 2x, and then you have y2, which is 1. Okay, now you graph it, and now from graph we should be able to see whether we got the right answer or not. So here, if you look at, we want this 3 minus 2x to be greater than equal to 1. So greater than equal to 1 means above y is equal to 1 line. And for above, you can see from here that the value has to be, x has to be less than equal to 1, or x has to be greater than equal to 2, because we are talking about this part. And for this part, the value of x is, x takes a value less than equal to 1, or x takes a value greater than equal to 2. Okay, so again, you can sketch this. So if I sketch it, something like that, and then here, and we want, this is 3 minus 2x, and this is y is equal to 1. We want this to be above, because it's greater than equal to, and above is this, and for this one, x takes a value, this is 1, and this is 2, so x takes a value greater than equal to 2 and less than equal to 1, for this graph to be above y is equal to 1. Okay, so next example is, the difference between this and the previous example is, as you can see in here in the absolute value, you have a quadratic factor. Okay, but the initial step will be same. We know absolute value of less than b means a is between b and -b. So which means x squared minus 5x is going to be between 6 and -6. A in this case is x squared minus 5x, b in this case is 6. Okay, if that helps, you can write it down. Now, x squared minus 5x is less than 6. I'm going to just separate them so that it's easier to solve. And now 0 is less than x squared minus 5x plus 6 by adding 6 on both sides. So which means we are trying to find when this is true, and x squared minus 5x minus 6 is less than 0 when this is true. And then we have to combine those two conditions to find the final answer. So in this case, let's see if we can factorize it. So this is 1 and 6. We need minus 5, which means this. So x plus 1 and x minus 6 less than 0. And here we have x, x2 and 3. It's negative, so minus 2, x minus 2, x minus 3 greater than 0. So x is greater than 2, or x is greater than 3 here. No, sorry. So now we need to actually use the Sine diagram here to find out the common region here. So I'm going to first draw number line again. So x is 2. X has to be actually -2. Right? So the factors in this case we got is x minus 6 and x plus 1. And the factor in this case we got x minus 2 and x minus 3. So now we are going to draw. So let's say this is 2, this is 3. Now, so to decide where the solution of this inequality lies, we need to, this is called a Sine diagram, which basically is a number line. And these values are called the critical values, which is the roots for this inequality. Okay, So this is 2. Now, less than 2, so 0 is available. I'm going to substitute 0. You don't have to show these steps. You can do those in your head. So if it's 0, and you, again, don't have to do all the calculation. You don't have to find out if you substitute x as 0, what is your left-hand side. You just need to have whether it's going to be positive or negative. So if it's 0, which means this is negative, so this is going to be positive. Between 2 and 3, let's say 2.5. So this will be positive, this will be negative, so this is going to be negative. From above 3, let's say 4. So this is positive and this is positive. So it seems like for this inequality, the solution is x is less than 2 or x is greater than 3. So this is what we got from here. X is less than 2 or x is greater than 3. Now, similarly, we need to do this one. So let's draw. So x is negative 1 and x is 6. So negative 1 and 6. Now, again, we are interested in signs, not the values. So here, let's do negative 2. When it's negative 2, this is negative, which gives me positive. Here, 0 is available, so I'm going to use 0. So this is positive, this is negative, so negative. 7, this is positive, this is positive. So here the solution is negative 1 less than x less than 6. Okay, so from these two we got this, but this is not the final answer because we need the absolute value of x squared minus 5x to be less than 6. So I'm going to draw these two, like combining this. So I have negative 1, then I have 2, then I have 3, and then I have 6. So from here you can see it's negative 1 to 6, so which means this. Then x is less than 2, which means this. And then x is greater than 3, which means this. So for the final solution, we need to look at the intersection point here. So from here, you can see. So this is going to be, we can't write like the solution is this, or solution is that, or solution is greater than 3. So what we can do here is, you can see from here, the solution is going to be, because it's going from minus 1 to 6. So that means minus 1 less than x less than 2, or 3 less than x less than 6. That will be the intersection of these two. So this is going to be the solution for this inequality. Now we can check it using calculator. So this is the final answer. Okay. Now, let's check it. So if you have here, let's erase. Okay, clear. Now, absolute value, again, second 0. And we have x squared, so x squared minus 5x, and then you have 6. Okay, and then graph. So the graph of this looks like this, and less than 6. And now from here, we want this inequality to be below 6. And you can see from here that this value has to be negative 1 to 2, and then this is going to be 2 to 3 to 6. So from graph, again, you can sketch this graph in your notebook, and from your graph, you can see we want the absolute value to be below 6. So what x values gives you x squared, absolute value of x squared minus 5x less than 6. Okay? Okay, the last one. So you have absolute value of 1 over 2x minus 1 less than 1. Looks like very complicated, but it's not. So first step, I know that when we have absolute value of a divided by b is absolute value of a and absolute value of b. So which means this is same as absolute value of 1 and absolute value of 2x minus 1, which is same as this. Now I'm going to cross multiply. When I cross multiply, I got this, which is 2x minus 1 greater than 1. Okay, I switched the positions. And now we know the property absolute value of a greater than b means a is less than negative b, or a is greater than b. Now a in this case, again, if that helps, you can write down b is 1. So here I got 2x minus 1 less than negative 1, or 2x minus 1 greater than 1. So 2x is 0 and x is less than 0, or 2x is greater than 2 and x is greater than 1. So the solution we got here is x is less than 0 or x is greater than 1. Now let's check graphically. Okay, clear. And again, second 0, absolute value. Now I need a fraction here, so alpha y. And then we have here function, which is 1 divided by 2x minus 1. And then I have here 1, okay? And I'm going to graph it. And from graph, we can see, maybe you need to change the window settings so you can see a little bigger here. But then again, the absolute value of this 1 over 2x minus 1, which is this graph, has to be less than 1, which means below the graph. And then you can see what values give you that inequality. And from here, x is less than 0 or x is greater than 1 will be your answer. Okay? That's it for this lesson.